Okay. So back in the day, right, early 90s, this is when most people were starting to become aware of the internet, right? Presidents were talking about it, saying they called it the information superhighway back in the day. Uh, and people were kind of excited about it. They did not know all the changes it would bring. And of course, how could they? So what it was, we had a few key phenomena, a few key states of the world at that time. So number one, the internet existed, but it was highly technical, right? It was something for specialists, not something that ordinary people had in their home. Number two, it was text-based. So basically, it was the difference between DOS and Windows. Now, if any of you guys have ever seen DOS, I'm not saying you would have, but for example, you might see this command prompt. It's probably disabled on this machine. We'll see if I can get to it. There you go. Back in the day, you had this system called DOS, disk operating system, that anything you wanted to do on your machine, you would enter in text commands like dir/w to display all of the contents in your current folder, right? Stretched out wide, W for wide. You'd enter text commands like that to get to where you needed to be. And if you didn't know those text commands, well, good luck trying to do anything, right? You had to have some kind of reference to figure out what all those correct commands were. There's probably a help command too. Let's see. No. Anyway, it's been a while since I've done this. Nope, so I don't recall all the commands myself. But we had DOS back in the day. That's how we got around our disk drive, right? To find files, things like that. The internet was not very different. To get to where you needed to be, you had to type in a bunch of stuff. You had to know the commands. It wasn't like the easy thing now where you just click on links, for example. So, but not very user-friendly, and it was text-based. Three, very few sites were out there. It was, again, primarily for research purposes. So if you were on the internet, you were probably involved in the research somehow. You got to what you needed to get to. But there wasn't a lot of things that were of general personal interest, right? So there weren't things like, I don't know, there wasn't much in the way of news or financial information, stuff like that. It was primarily, again, for specialists. And last, there was a proliferation of hardware models. So this was a difficult thing. Because we were just starting to see the leading edge of the explosion of computer models that is pretty much standard today. So what would happen is that people had to design websites that would work for any machine, and we needed browsers that would universally translate web pages more or less the same way on any machine. So this is what was going on, you know, roughly 30 years ago. So the internet was primarily for specialists. Number two, search engines as we know them didn't really exist because there were a limited number of sites. You just navigated them basically like file folders to find what you needed. So search engines weren't really necessary. For businesses, the internet existed, but things like EDI, electronic data interchange, proprietary versions of that were typically better. You'd set up a direct connection between you and some other operation instead of getting onto this internet and using somebody else's system. And last, universal languages were needed. If you wanted to say run an application through the internet, you needed to have that written in some kind of language where it could run on any machine. So key things. Number one, Java. So this, again, if you've taken IDS 201 from me, you know some of this stuff already. Let's see what we got here. If this article is still available, I believe it's from 1995 or 1996. This is from the early days of Java. There we go. Java for Embedded Systems from 1996. So it talks about why Java is different from other languages. But the big thing about it, most computer languages, we want to get back to PowerPoint. Most computer languages are designed to run on a specific set of hardware. Okay, so this is, if you've taken 201, you've seen me draw this picture before. So back in the day, back in the 90s, right, a common language would be C++ for running applications. And here's your hardware down here. C++ is written for a specific hardware configuration. If you write a program there, you directly access the memory locations where things happen. So for example, to draw on the screen, you first have to, one, find the graphics card memory locations. Number two, change the values at those memory locations. Okay, that's how you draw. But what this means is number three, different card or other hardware means you need to update your code. Okay, consequently, many hardware models requires multiple versions. Okay, so a language like C++, again, specified for a particular hardware configuration. And this is how come when you go to the game section of Target, for example, and you see there are different versions. You see some games for PCs, some games for Macs. Yeah, they're written in languages like C++. They can squeeze out more usage of whatever hardware is there. They can do more, but the downside is you have to write a different version for every kind of hardware. Okay. Java, on the other hand, has this intermediate layer called a Java Virtual Machine, or JVM. So, Java Virtual Machine, basically, you have this back and forth with the hardware where current configuration is mapped to the Java Virtual Machine. So it doesn't matter what kind of hardware you're using. When you install the Java Virtual Machine on your device, when you install Java capabilities on your device, it's going to look up where all those things are on your machine through an automated process, and it's going to write all of those memory locations in the Java Virtual Machine. So when you're going to run a program, let's do that in, we'll do it in a different color. There we go. Boom. And boom. So writing code means writing code, any code gets translated through the Java Virtual Machine. Okay, and then JVM tells the graphics card what to do. So if you want to draw a picture on your screen, for example, you have some standard code in your program that says basically draw this picture on your screen. That command gets sent through the Java Virtual Machine, which already knows where the memory locations are for the hardware. Okay, so consequently for Java, you have this thing called WARA. Write once, run anywhere. So you only write the program once. Once you figured out that it works, it's good to go. Now, it's not the reason why they don't use it in video games, for example, is they tend to use the lowest available capabilities. So if there are standard, features available on all machines, yeah, they're going to use it, but it's not going to use some of these cutting edge tricks that other languages like C++ might, because again, Java tends to use the lowest common denominator of what's available. Anyway, but that was a very important thing for early on in the internet. If you did web apps, for example, what you often did you would install a Java program on your device and then run it through the web browser. Those were called applets, and we'll talk a little bit about them next lecture. Okay. What else? For browsers, there were a bunch of browsers early on, most of which do not survive to this day. So there was Internet Explorer, which, yeah, it exists, but if you're going Microsoft, you're probably using Edge these days. But Internet Explorer is actually useful for some older sites. For example, a lot of government sites might want you to use Internet Explorer because they're not updated to use things like Edge yet, strangely enough. Other things like Mosaic, that was the one they devised at the University of Illinois Champaign-Urbana, which later became commercialized as Netscape Navigator in the mid-90s. And then a couple World Wide Web, Lynx, whatever. These were browsers that were popular back then. And the key takeaway is mostly they don't survive anymore. Been a lot of turnover. Okay. So following the early days, we eventually had this window where the internet began to get widely adopted by ordinary humans. So what did we have? Starting around 1995, you had applications like America Online. I'm thinking if I have my discs here with me. No, I probably don't. There was a window where America Online was sending 3.5-inch discs or eventually CDs to pretty much every house in America every month, trying to get them to sign on. So what we had, first of all, web browsers became available for ordinary people. So ordinary people were getting out there and using the internet, right? They were basically much easier to use. They weren't text-based anymore. They were, click on things. They were more like Windows. Number two, consumers became used to online transactions. So back in the day, in the 90s, you'd see a lot of commercials where there would be some old person who was nervous about buying something online. They say, well, I see all this stuff about internet shopping, but I don't feel safe. I'm just talking to some stranger. How do I know what they're going to do? And I thought about it, on the one hand, I can kind of see it because a lot of these companies had just come up out of nowhere. So people didn't really know what they were doing, if they were real companies or just scams. But the other thing, catalog shopping had been around for a very long time, right? If, longer than credit cards for sure. So the idea that there was some unique danger to it, to going onto a website and using your credit card, didn't make that much sense to me, because literally back in the day, if you ordered something from a catalog, you got on the phone and you read your credit card number to some person on the other side, right? You are literally giving the other person your credit card number. So, the fear of all that always seemed kind of screwy to me. Anyway, but by the end, yeah, online shopping was pretty standard. The internet was roughly doubling every year, right? In any metrics you care to measure, just in terms of number of users, for example. And last, people were becoming worried about security. So in 1995, in the early 90s, there weren't that many security troubles on the internet because, again, it was mostly for specialists. Outside people weren't that interested in digging around in it. But, by the year 2000, online shopping is becoming a thing. People have their credit cards available to use. People are figuring out, hey, the internet is a pretty good vector for any kind of scam I might want to run. So what are the implications? Well, number one, by the end of the 90s, businesses need websites. If you are a business and you don't have a website, it's probably the beginning of the end for you, because you're not going to catch up from that. Number two, websites have to be able to handle transactions, right? In 1995, you had very few websites that were capable of handling online transactions because online shopping wasn't really a thing. By 2000, yeah, there were lots of them. The ability to handle traffic and fulfill orders became entirely decisive. So this was a big thing for companies like Amazon. I mean, sure, it was really nice that they had recommender systems and they had a nice product selection, but Amazon wasn't the only operation that had a big product selection. And they weren't the only, by the end of the 90s, they sure weren't the only one that had a recommender system in place. What really cemented Amazon's awesomeness was that they could handle the scale, right? That orders would come in and they would actually get them all out on time. They were able to keep up with growth. So that ability to handle both the network traffic and then the physical side of putting together packages, that was a huge thing. People knew that when they went to Amazon, they would get their order shipped on time. And last, most of these online businesses were losing money. So Amazon had been around for a few years by then. By 2000, didn't show an actual profit for another 10 years. Now, a chunk of that, of course, was due to accounting, right? Amazon doesn't really want to show taxable income. But the other thing is they just kept putting money back into their business for a very long time. And this was true of most businesses, whether you're talking about Google or eBay or some of these others. If they wanted to keep growing, they had to keep putting money back into tech to keep their performance good as they got bigger. So some key topics. If you wanted to look at some of these, you can. I'm just going to walk through them. So number one, America Online. This was the first introduction to the internet for lots of people. America Online, it still exists now, but it's been rebranded as essentially a kid-friendly ISP. So they don't have access to certain types of objectionable content. What else can we say about them? Towards the end of the 90s, there was a huge merger between America Online and Time Warner, something like or close to 100 billion in market cap at the time. They were both very large companies. And the idea was they were going to be sort of something sort of like Netflix, right? That Time Warner had this massive catalog of, you know, films and other kinds of media. America Online was the premier way that people got to the internet. So there was this idea, again, that basically AOL Time Warner would be this kind of streaming media giant a little bit down the road. But in fact, it never really took off because the big thing was America Online fell behind in the broadband game. So as broadband technology started becoming a big thing in the next decade, they weren't able to keep up with their competitors. They were still tied. Their business model was more around dial-up and DSL, and the whole video thing just did not turn out to be nearly as profitable as anyone had hoped. So big bust was where it all ended up. Number two, this Toys R Us Christmas debacle, right? So around 1999, for many people, this was the first year where they tried to do a lot of online shopping. So Toys R Us, right, which you may know has recently gone bankrupt, they said they had a big commercial push, big advertising campaign telling people, hey, don't fight the crowds this year. Go to our online site and you can shop there. And people thought, hey, that does sound like a great idea, because the only thing worse than trying to shop in crowded stores is trying to shop in crowded stores packed with kids. So a lot of people stayed home, tried to do this sort of online shopping. Well, what happened, Toys R Us's push to get people to shop online was actually far more successful than they could have imagined. In fact, it was so successful that they could not do anything like keeping up with the orders. They got something like 10 times as many customers as their optimistic projection suggested, and they couldn't fulfill all the orders. So what they ended up doing was giving $100 vouchers to everyone who didn't get their products on time. And so they were able to salvage the good name of their business more or less, but it was still, you know, a huge and very expensive problem for them. Last one, content and security. So I'll actually bring this up if it's still there. This one is an article from a grumpy old man in 1995. Okay, this is one of the few pages from the 90s that's still active. So 1995, we had this guy who said, the internet's out there, but it's not all that. I'm not that thrilled about it. So, and there's actually a few points here that he makes that are valid. So number one, this here, right, back in the 90s, before search engines, this was a big problem, trying to find what you were looking for. If you wanted to look for some particular factoid, for example, he has here Battle of Trafalgar, he's looking up that, and you know, there's a whole bunch of stuff, right? One's a biography, one's a computer game, one's a picture of a monument. They didn't have Wikipedia back then. Google search wasn't really around. There were some search engines, but they weren't especially helpful. They couldn't filter out the important from the unimportant. And yeah, I can see how he would get frustrated about that. Okay, there's some other stuff. Let's keep people quiet, huh? There was some other stuff. I want to mention this. This cyber business, right? This was the opinion of a grumpy old man in the mid-90s. So he said, we're promised instant catalog shopping, just point and click for great deals, order airline tickets over the network, make restaurant reservations, negotiate sales contracts. Stores will become obsolete, right? And much of this has in fact come to pass. Amazon right now is the majority of retail in our country. So, and he's saying now, oh, how come my local mall does more business than the entire internet handles in a month? Even if there were a trustworthy way to send money over the internet, which there isn't, the network is missing a thing called salespeople. So apparently this guy, he wants to go out to shop so he can chat up people, which seems odd, but most people not in that same boat. And again, it's worth mentioning, these were serious problems back in the 90s, but, you know, nowadays they have largely been solved. Okay. So that was just a window back to the attitude, and that was the attitude pretty common among a lot of older people back in the 90s. What do I need the internet for? I'm fine with things the way they are. I like to go out to the store. All right. Following that, you had the shakeout, right? Or the dot-com bust. So what happened is that all the smaller players got crushed by the economies of scale by the bigger players. For example, there was a window around the year 2000, 2001, something like that. I was involved in retail at the time, and one of the sales reps who had come through was telling me about an uncle of his who was running an online site for selling used books. And sure, okay, that might be a viable business, but he was trying to talk me into giving like a 10,000 for a business loan at the time, and I was like, I don't think so. I don't think so, because if you're not big at this point, you're kind of doomed. It's just not going to work. So anyway, this is what happened. You had all these small players. They were trying to set up businesses, but in many cases, only one can survive. It's the nature of the game. So if you're some big retailer like Amazon, you build this massive platform, right? All of your systems for crunching numbers and doing order fulfillment, all of that. And it's going to cost you about the same to build that platform, regardless of whether you have a few customers or lots. So once you get bigger, those costs become distributed over many sales. I don't know what's going on downstairs, but it's loud. Those costs get distributed over many customers and consequently become a relatively small fraction of your costs. But if you're small, then the cost of setting up that platform remains big. It's a problem. So what we had, all these little small businesses, they kind of went away. And in most cases, what followed is that you had one big company dominating whatever sector of the business world you were talking about. So for example, for search engines, you had Google. For retailing, you had Amazon. In 2000, for Microsoft's bread and butter was Windows. They were selling that, and of course, other things like Office, and Cisco for networking. So in all these domains, you had like one big name and a bunch of lesser names. There was still some competition around the edges. For example, these days we see that Microsoft and Google are still battling a little bit around the search engine stuff. I mean, Google's the clear winner, but Bing exists and it's doing more business than you might guess. Likewise, let's see, Amazon and Microsoft and Google are all competing in the cloud world. So yeah, there's still some competition, but basically the boundaries have stabilized. And what we also see last is that these big online businesses, even if they're not profitable in the accounting books, they are making a lot of money. They're just putting it back into the business for now. So again, Google, Amazon, Microsoft, Cisco. Microsoft have been profitable for a while, Cisco as well, but Google and Amazon in particular, they were starting to make lots and lots of money with the prospect of even more money on the horizon. So the implications of all this, competition is still pretty intense, but the industry boundaries are stabilizing, right? Basically, nobody's booting Google out of search. Nobody's booting Amazon out of retail. The one exception to this, I would say, is social media, right? So early 2000s, the big precursor to Facebook was MySpace. MySpace is like the only example of a really big and fairly successful online business that just kind of went away. I mean, you could argue that America Online is another one, but I wouldn't put that in quite the same category. America Online was a long, slow decline. But MySpace was, it felt like kind of overnight, everybody went from MySpace to Facebook. And then MySpace basically ceased to exist. So, but in general, yeah, the industry boundaries are stable because people say, okay, Google, you're doing search, that's your thing, that's great. We're going to do this other stuff. And the way these businesses keep growing is that they create new revenue streams. So by 2000, the internet's still growing, right? The population of users may be growing 10, 20% a year still, but it's nothing like that 100% a year they were seeing in the 90s. So businesses, in order to grow, they can't just assume that they'll get more customers and sell them the same old stuff. They have to sell them new combinations of things. For example, Amazon used to be just books, but they branched out into other sectors of retail, things like streaming video, things like Kindle, and eventually into cloud services. So yeah, people found other ways to make money. Same thing for Microsoft. Microsoft used to make money on Microsoft Office and Windows. That was their big stuff. But nowadays, it's not. They make a lot of their money in other areas. So all these companies, they were making new revenue streams in order to find more ways to continue growing, even as the growth of actual customer count started to stabilize. Okay, so a few big topics. So number one, win big or go home. A couple articles here, if you want to check those out later, basically found that the best predictor of whether an online business would thrive or wither away was simply how fast it was growing. But that's partly because growth encapsulates two things. So if a business is growing, we know a couple things. We know a couple things. Number one, sales are going up, which means either more customers or more dollars per customer. Either way, right? That's a positive. Means the customers are happy with what you're selling. Okay, so growth isn't just, a thing that exists, that comes out of nowhere. Growth happens because customers are happy with what you're selling. They either tell other customers, hey, go check this site out, or they keep coming back more often, right? So growth is a symptom of the fact that you have a pretty good business model. Okay. Number two, of course, when sales go up, your costs for things like system development and other variable costs, well, put that as other costs distributed over sales will go down. Basically, less cost per unit sold. So your business metrics improve. As you get bigger, right, all these various types of fixed costs you have, they're going to get spread out over the number of units you're selling. And so they're going to represent a smaller share of that. Okay, so that's good. Last thing, number three, if you are growing faster than your competitors, you are denying them all these advantages, okay? Which means your competitive standing will improve, okay? So for those three reasons, basically, if your business is growing quickly, number one, that's a good sign about your business model itself. Number two, your costs of selling stuff are going to go down. And number three, you're taking that ability away from your competition, right? These are all very good things. Now, businesses stay stable when they grow, all right? There was a window where a lot of businesses could have maybe caught up, but I'm going to draw the old picture I draw with Facebook and MySpace. Okay, so we're going to label this why Facebook in 2020 is far more stable than MySpace in 2005. Okay, let's stretch that out. Here's the reason. So if we look at the growth of total internet users over time, no, that's not what I want. It's going to look more like this. Okay, that'll do. Okay, so all this is internet users. Now, let's do some years down here at the bottom. So this can be 2005, and over here can be 2020. Okay, so MySpace at the time, let's do those, I don't know, we'll do it in green. MySpace at the time maybe had a sliver of like this, right? Let's say maybe half the people on the internet had MySpace back then. Roll it back a bit. Looks something like this, okay? Facebook comes along and is tiny like this. But look, at this point, they both have, if we stack these two things up together, right? Sure, there's not many people that aren't covered by one or the other. But look what's happening over the next few years, right? We can copy this stretch here. If we stretch it out over to here, just a few years down the road, maybe like by, 2008, something like this, if Facebook is getting all the growth, all the new customers, it will dwarf MySpace, right? Because this is the slug of customers that Facebook can get as far as the new ones. If it's getting a big chunk of those, in a few years, it's going to be just as big as MySpace. If it keeps on out getting new customers, and that's without even poaching anybody from MySpace, right? If it poaches some more, then the difference gets even worse. Nowadays, well, how many accounts does Facebook have? Facebook has roughly 2 billion, okay? Has something like 2.3 billion accounts. And let's say most of those are actually humans, not bots or phony traffic, whatever, has something like 2.3 billion accounts. That's a huge stretch. That's a huge fraction of the, North America and Western Europe where Facebook is dominant, right? So Facebook, as far as that chunk of the world, has something like this kind of share. Nobody's going to come along, right, and just make that much more in terms of growth. Even if you capture all the growth in internet users, and there's not that much left to be squeezed out at this point, they have to basically steal a whole bunch of Facebook's existing customers in order to succeed, okay? Back in 2005, Facebook did not really have to steal any of MySpace's customers right away. They just had to do better in terms of grabbing the new ones. Okay. So we have that. Other stuff, other consequences that we saw in those days, falling prices of technology and related services. So with the dot-com bust, one of the underappreciated facts, a lot of companies had built up a tremendous amount of infrastructure, particularly high-speed fiber optic cable. There was one company called Lucent, which was an offshoot of AT&T, that went bust during that time. So they were a big one in terms of high-speed internet. But what that meant, when a company goes under, it's going to sell off its assets at a fraction of the price, right? It's just, if you unload all that capacity, all that, all those business assets in a short window, you're not going to get the full price for them, right? You're just going to sell it to whoever's there and wants to buy it at that moment. So these companies were able to get big chunks of high-speed data capabilities for relatively low prices, the ones that survived. That meant that those companies could then sell those services to customers at a much cheaper rate than they might have otherwise been able to. So what that did is that really sped along the growth of high-speed internet because, again, the collapse of the companies that had built it in the first place made it possible for other companies to pick it up and then, at low prices and then sell it at a similarly low price. So cheaper high-speed connectivity, big wave of mergers and acquisitions. Again, going back to the point that you had to be big in order to live. So a lot of these companies were joining together either voluntarily or not. And all that helped to bring down the prices, particularly for high-speed internet. Following that, we had the mobile era. So starting around 2006, I would mark that with the advent of the iPhone. So what we had in those years, going in, at first there were just Blackberries, right? And if you've never seen a Blackberry, it kind of looks like a miniature typewriter. So this is one of those, I'll bring up a picture. if this works, if internet works today. I don't know what's going on. There we go. Jeez. Thanks, Google. Thanks for being slow. BlackBerry device. Okay. This is what they look like, right? There's a good one. Okay, so it looks like I said, kind of like a little typewriter with the screen. And people were very happy to have them back in the day. But of course, when the iPhones came along, that's what people went for. So, there's BlackBerries still do have a dedicated following though. So we had BlackBerries. Then after that, there were iPhones. People loved their iPhones. And then finally, where we are now, there are iPhone clones. Other stuff, m-commerce started to be a big thing. Now, all the visions that people had of m-commerce, they haven't entirely come to pass. The idea is, that things like your smartphone will be used for all transactions everywhere. And yeah, you can use it, but people still use a lot of credit cards. People still use cash. It hasn't quite caught on as much as some people thought it would. Even a lot of things that get classified as m-commerce, like if you buy stuff through your phone, for example, if you order groceries to get delivered, yeah, that's m-commerce if you're doing it through a mobile device. But the way people are doing it, it's basically feels the same as doing it, on a laptop or a desktop. So yeah, it's m-commerce, but it's not m-commerce in the way that people really meant it back then. Other things, social media. Social media was huge for mobile devices, right? It was, in many ways, it was the thing that justified having a smartphone as opposed to an ordinary phone. And the great thing about apps like Facebook or other stuff like Angry Birds was that it gave you something to do if you had like 5 or 10 minutes while you were standing around waiting for something to happen, right? If you're waiting for a bus or waiting for an elevator, they were great apps for that sort of short attention span window. Last, consumer and business adoption, right? So once customers started buying all these mobile devices, well, businesses had to follow with coming up with mobile versions of their own websites. So 2006, it was very rare to see a specifically designed mobile version of a website. Now it's pretty much standard, right? And it's been standard for quite a while for businesses to have mobile versions of their site and non-mobile. What you also, of course, see now is there will be app versions of a website as well. So one thing, I still look at Quora through my regular internet browser, but it always wants me to install the Quora app on my phone. Anyway, so implications. Number one, platforms have to fully support mobile access, right? If you're not supporting mobile users, you're losing out on a big share of business. Number two, external users, right? So both internal and external. External for customers, internal for your own employees. Now, mobile devices present a number of interesting security challenges. The big one is simply, if you have people coming in through your doors and sitting down at a desktop, well, guess what? You know who they are, right? They made it through a security checkpoint. You verified their identities. They log in at their machine. If they're not who they say they are, the dude at the next cubicle is going to say, hey, you're not Joe. You don't belong in here. Security, help, right? But if somebody's at home using a mobile device to access the network, then you don't have all those checks built in. So again, security is going to be weaker. You make people jump through some extra hoops, like having multi-factor authentication. Less control over quality of service. Yeah, one of the problems with mobile devices is that if there are a bunch of them all in one place, their connection quality is not going to be very good. For example, McDonald's down at the Metro at Ogilvy Station, downtown Chicago, McDonald's has free Wi-Fi. And if the station isn't real busy, if it's like 9 o'clock at night or something, their Wi-Fi is adequate. You can use it to get on and do stuff. But if it's rush hour or anything like busy in the middle of the day, yeah, it's going to be pretty worthless because there'll be like 1,000 people in the vicinity. And even if they're not all using McDonald's Wi-Fi, there'll be so many devices in the area looking for Wi-Fi signals that you won't be able to, get much data through. So again, less control over quality of service. And this is a problem that, businesses have internally as well. You can have sudden influxes of people, like when the business first opens or when it breaks for lunch. You could have basically a system overload near the exits. At the end of the day, when everybody's leaving, same kind of thing. I even see these fluctuations at UIC, University Hall. There'll be certain times where I know there's a lot of traffic, a lot of people are turning on their machines at the same time or doing stuff at the same time. You can notice the fluctuations in connection quality. And last, businesses tend to have to make a decision about whether they want to be flexible or whether they want to be bandwidth efficient, right? So you could either set up a system that works pretty well for your current needs, or you can set up a system that maybe doesn't work quite as well for your current needs, but it's designed to grow it well in the future. And yeah, that's generally what businesses have to put into. Because if you're a successful business, your data requirements are probably growing around the order of 50% a year. You have to plan for growth. Let's see, we got a chat thing here. What's happening? Let's see who we got. No compromise. No compromise for what? Well, I mean, you get some aspects of both, right? I mean, even if you have a fairly stable system, you could still add on new machines to it. It's just, it's going to be more of a headache. The question is, which thing is going to be more of a headache? Are you going to have a little bit of, well, it's about finding what fits your needs, right? So the question is, it's about finding the balance. It's about finding what fits your needs. If you are growing quickly, right, and you plan to grow quickly in the future, yeah, you need to allow that in your systems, right? So for example, let me specifically say what I mean. Give a more concrete example. Suppose we map out your business as being, whoop, trying to do this. Suppose we map out your business as something like this. Here's your business. Here's your business layout. Okay. And maybe you have wireless towers here, 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 here. Okay? And you find at various points during the day, some of these get overloaded. Well, one thing you could do is pack in more wireless access points, right? But more wireless access points is not necessarily going to fix your problem if, for example, you have a lot of people walking through that are in range of multiple ones, right? It's not necessarily going to solve your problem. Likewise, planning for growth, all of these wireless access points, right, however many you have, those have to be connected through switches to various points in your system. So I'm going to put a couple wireless access points here. They're all going to be connected through these switches. Now, if you have a lot of devices, you are going to need a lot of switch ports, right? So switches have ports where devices connect, okay? And for example, I don't know why it's not, I must have hit enter, where devices connect. More ports are expensive, but can allow for growth. Okay, so if we talk about what these switches look like for terms of hardware, right, they're basically a big box with a bunch of ports, right? Something like this. And the bigger ones that can handle more data, can handle more devices, are going to cost more. So same for data speed, and back in the day, also for mobile and wired traffic, okay? Back in 2006 anyway. So nowadays they tend to be support both, but back in the day you wanted separate ports for the two kinds of devices. So you could either design a system that was pretty stable, right? Worked really well, had enough ports you need, just barely, but wasn't very easy to modify and you weren't planning on making it bigger, but it was going to be cost effective, right? Because it was basically just what you needed at that point in time. On the other hand, you could cough up a little bit more. You could get these bigger switches with more ports and higher speed ports to allow for growth, right? So it wasn't super efficient in the moment, but it was going to be better if you were planning that stuff was going to be growing anyway. And you kind of had to find that balance that was going to fit your needs, because you don't want to just buy all the hardware in the world, but on the other hand, you don't want to have these kind of data capacity crunches either. Okay, so I hope that makes sense, since we're talking about these specifics. So when I say flexible or bandwidth efficient, yeah, having that ability to handle growth is going to cost you something extra because you're going to have to buy either more hardware or more expensive hardware. Okay. We have some topics here. So the iPhone, if you're interested in how the world was circa 2006, we could peek around in there. Like I said, that's basically a history lesson. But, you know, the iPhone, it was a very big deal back in the day. A couple of things here, just some old predictions, right? So here it says there'll be as much mobile commerce in 2018 as e-commerce in 2013. Sure. We got a chat here. Let's see what we follow up. Oh, well, there you go. Yeah, see? So this dude, he can vouch for some of this stuff. He was an IT admin years ago. All right. This is an interesting site, an interesting article here. So trends for the second half of 2016. So it's a little walk down. I don't know what's going on. It's a little slow. So a little walk down the browser stuff. Mobile commerce trends for the second half of 2016. We can look and see how much of this has come to pass. All right. And in fact, I briefly checked that this morning. Let's see. We do not need more windows. Okay. So we'll zoom in a bit so you guys can see a little better. There we go. More money spent on customer experience. Yeah, I don't really care about that. Mobile wallet and point of sale improvements. Yeah, I see this, right? Mobile wallets have become kind of a thing. My wife goes to Starbucks and she uses the app for that. They go to Target, you know, there's an app for that. You can buy stuff. So yeah, for sure. At checkout, this is totally a thing. And you didn't see it that much even 5 years ago. What else? M-commerce versus, e-commerce. Yeah, M-commerce is growing faster. 2016, that number is expected to hit 31 billion. I don't know, right? I mean, I guess maybe mobile M-commerce has gone up, but again, it's important to distinguish. We say M-commerce, a lot of times that's not qualitatively different from anything you would do on a non-mobile device. It's just you happen to use an app that's on a mobile device. It's really weird, right? Because if you wanted to do this stuff, you would get a big screen and you would look at it and you would get a good view of everything. But I guess what happens is people just happen to be on their phone at the time and the phone is right there in their hand already. So they just start using the app to do their stuff. I don't know. If it were me, I do most of my shopping on a laptop. My wife prefers the mobile device, but in her case, I think that's because the mobile device never fully leaves her hand during the course of the day. So I don't know. I could look up a quick stat on that. Let's check it. M-commerce versus e-commerce 2020. Let's see. Aha. Yeah, that's what we see. What's this? Okay. So we're saying percentage of e-commerce sales. Yeah, even now, 2020, M-commerce is 1/3 of e-commerce, right? So it's still there, but it's not, you know, it's not taken over yet. Maybe it will one day, but there's a lot of shopping stuff. It's just nicer to have a big screen and a full keyboard. So it really depends on what you're doing. Okay, but that's been the trend generally for some years now, is that more transactions happen in mobile devices, but you know, for certain types of products, typically expensive ones, people like to look at a lot of pictures, and it's usually easier to do that on a you know, full-size screen. Okay, so there's that. And other thing, read write web. So we talked about that the other day. Okay, this is just a little thing here about the idea that people can change what's on the internet as opposed to it all being on the server side. So ordinary users, like on Facebook, they can show up and change stuff, and then that's just part of what's there, right? It's not that they need access to the, you know, to the server side of things, you know, from inside the business. Yeah. All right. I'm going to close out these things. Anyway, so you can look at a little bit about that if you like, just more history stuff. All right, next this brings us to cloud. So what we had is phenomena there. Number one, big data keeps getting bigger. So yeah, there was a lot of data and there just kept getting to be more and more and more of it. And so businesses had all this data they had to manage, and so they needed cloud services to do it. Basically, the problem was, even though storage is cheap, the ability to access the data quickly, that's not so cheap. So imagine if you are putting data in a garage of sorts. If you just want to pack stuff in there, sure, you can pack stuff in there. And, you could build a new garage, and as these things go, that's not terribly expensive. But if you ever try to find something in a cluttered garage, it's a colossal pain, right? You got to pull out a bunch of stuff, get things out of the way, look for what you're looking for. Hopefully you find it in a reasonable amount of time. That's kind of the mess. So storage is easy, but having a system that's set up for fast and efficient retrieval, that's not so easy. What we got here? We got a chat comment. Yeah, for example. Yeah. So anyway, what we have here is a problem in terms of cloud that businesses didn't want to handle all this data themselves. And a big reason for that is this peak to average ratio. So let me explain that for a moment. I'm trying to get some extra windows out of the way here. Okay, so a normal business will have its profile of data usage, right? Its network traffic looks something like this maybe during the day, right? So there's it's quiet for a while, then there's a spike in the morning, it's busy, maybe a little break at lunch, spike in the afternoon, then kind of done, something like that, okay? So what does this mean? Well, first of all, even though these are average times, they might occasionally experience busy spikes up to like here, right? Or here, or up to here, or up to here. They're going to experience these short, sudden spikes. Now, if they want to have good service, right? If they want to have good quality of service within their networks, they are going to need to plan around that. They're going to need to have basically something like this much capacity, right? Business will need this much capacity to avoid quality of service troubles. Okay, but the problem is providing this much capacity is kind of a waste, right? What happens on the other side, imagine if you're running a website, and again, same thing, it's busy some days and some parts of days, but otherwise not so busy. Well, if you're gonna have a situation like that, it's basically the same problem. What it means is that, like for websites, you need extra machines to handle the visitor traffic. Okay? And most of the time you don't need them, but most of the time you don't need them. Now, in 1996, right, let's say 1999, maybe you had 10 servers to meet peak demand, okay? But most days you only needed 2. And that's gonna cost you something, but you can manage. So 8 servers is manageable, right? Is bearable, I would say. It's a cost, but you can live with 8 servers. But by 2009, right, data keeps growing. Maybe you have 500 servers needed to meet peak demand. But most days, you only need 100. Well, 400 servers is pretty expensive, right? You start looking at that, you're like, maybe we're not going to do that. But forecast for 2019, right? Maybe you'll need 10,000 servers, but only mostly use 2,000, and 8,000 extra servers, mostly idle, is not really sustainable. Especially when the future say, well, you're going to even need more machines in the future. Okay, this is the problem that businesses were faced with. When they're at small scale, yeah, if they have a few extra pieces of hardware, that's manageable. But as the data requirements got bigger and bigger and bigger, they started needing more machines. If they're still maintaining this same peak to average ratio, then that starts being a really huge amount of hardware that's just sitting idle most of the day. So businesses were very highly motivated to join cloud services to try to solve this problem, to keep their costs under control. Okay. So what are the implications? Well, when businesses decide to go with the cloud, first of all, they have to decide what will and what won't go to the cloud, what stays internal, what doesn't, and then which cloud service they're going to use. So the other thing is lower cost of business intelligence, because businesses now have lots and lots and lots of data and the ability to crunch all those numbers pretty quickly. Business intelligence of all kinds has become a lot cheaper. So all of this machine learning stuff has become a really big thing in the last 10 years or so, because businesses are able to outsource a lot of the system development side to other operations. Okay, so if you're interested in this stuff, right, cloud computing trends, this one actually links to a current one. Last I checked, maybe it's the other one that does. Yeah, this one. Okay. 2020 State of the Cloud Report. If you're interested in looking at, what's going on with the world of cloud, some stuff here. I don't know. If you're interested in this stuff, you're keeping up with it. But basically, a lot of businesses are using cloud, and they're starting to use even more of it. They're branching into multiple cloud vendors. There's a lot of what's called multi-cloud. Businesses are using much, much more cloud services than they were 10 years ago. Okay. Where's my slides? All right. Other thing, if you're interested, Amazon Web Services. There's a set of case studies here. Now, because this is provided by Amazon, one thing we know for sure, right? All of these case studies are basically going to follow the same format. They're going to be, we were a business, we had some problems, we showed up to use Amazon Web Services. Oh my goodness, it not only met our expectations, it exceeded them, and now life is wonderful, right? These are case studies that Amazon likes enough that they're going to post on their website. They're not going to be stuff like, yeah, we sunk $100 million into Amazon Web Services, and it kind of sucked, and now we're using Microsoft Azure instead. So, expect what you're going to get. But there are, if you want to read a couple of these just to learn about the sort of problems that businesses are facing, yeah, there's some good case studies in here. Okay, so what's going on now as far as ongoing trends, right? Certainly there's more data, there's faster processing, there's smarter processing, by which I mean prioritizing what needs to happen. All of that systems are getting better at. So data traffic, it's really, really cheap compared to what it used to be, but it's still not free. So businesses have to put in a little bit of concern to what they're doing. Machine learning has become really big. Analytics generally has become bigger than it ever was. I will mention one thing about machine learning. So some of you guys may eventually take a course in this. But machine learning essentially means building a probabilistic set of predictive rules. Basically, predict an outcome for some situation. So the example might be, imagine if on YouTube, someone has uploaded, I don't know, Star Wars in 10 segments. Okay? And chances are, if you watch segment 1, you'll watch segment 2, right? So in YouTube's machine learning algorithm, they'll recognize this pattern, right? Viewers who watch this, viewers who watched number 1 often watch number 2, and that's why segment 2 will show up as, you know, in the side window as a next viewing option. Right? That's how YouTube does it. For anything that's on there, any kind of song you watch on YouTube, any kind of video, you know, it'll look and see, oh, people who watch this also watch that. But the thing is, it's all probabilistic. So machine learning rather, is useful for situations where precise accuracy isn't necessary, right? If you're like which ads or alternate videos to show, right? In aggregate, the results will be optimal, but there's no guarantee about a particular user's viewpoint, right? So you might watch this first Star Wars segment and you say, ah, this is garbage. I'm not even, you know, it's ridiculous. What's this shit about the Empire? Who's this guy walking around in a black mask that can't breathe? It's ridiculous. I'm not even going to watch this, right? So for some viewers, it might not fit their needs. Machine learning is not going to guarantee it works for everybody. It's just going to pick the one that has the best probability of success. So machine learning is great in those kind of situations. But if you need to figure out the results of a particular situation, right, what's going to work best for this one user, then machine learning is not going to be terribly helpful. Okay. Anyway, moving on. So, topics. What we see as far as ongoing trends, businesses are using things like machine learning to optimize their advertising models. We're also seeing a lot of voice-driven tools, right, in the last few years. Things like Alexa, Siri, Cortana for Windows stuff. All of that is, you know, part of the next generation of hardware. And it's, in my opinion, amazing what they're able to do as far as voice recognition and natural language interpretation. So pretty neat. Other things, smarter, customized, more ubiquitous internet, right? So a lot of this, in a sense, is kind of everywhere. So what they call the Internet of Things is all the little devices that you don't really think of as being computers that are still connected to the internet, right? So for example, things like if you have a Fitbit or some comparable device, then yeah, that's part of the Internet of Things, right? If you have a smart heating system, that's part of the Internet of Things. We have some of our lights hooked up to our Alexa now. That's part of the Internet of Things, right? So all of this stuff is creating a lot more devices with more frequent interactions. Yeah, anyway, it's a whole big thing. Also, security issues. So Internet of Things devices are often not terribly secure. People haven't figured out exactly how to attack them. But I remember a few years ago, I was doing a little bit of research into smart power grids and basically how hackers might try to attack those. Yeah. Anyway, it's a serious concern, of course. Last thing, I believe this is the last thing. Yeah. Intent-based networking. So this is a thing that's come out pretty recently. There's a lot of businesses that fundamentally do not want to be in the networking game, right? They're manufacturers or other kind of services. Yeah, they have networks, but that's not really what they want to do. They don't want to manage this stuff. Just like they don't want to build systems for data management, they push that off to the cloud. Same thing for networking. They want to get a system that works that they don't have to actually spend a lot of time managing it themselves. So the old model was that you would have humans, right, network designers, arrange these system components and apply policies to meet whatever the operational requirements are. Things like which applications and which users have priority over others, right? So your most important real-time applications, those would get priority in the network traffic. Other things like people looking at Facebook or eBay during business hours, that would have a far lower priority. But in the new model, humans don't do that. Humans specify the requirements. Humans specify the end goal, and the network is automatically going to work itself to achieve them, right? So part of the problem with the old model is you would have to specify everything. You would have to specify, this is what we want to have happen, and this is how we want to have it happen. And if you didn't put a rule in just right, then the system wouldn't work the way it was supposed to. In the new model, right, you still have to classify the traffic. You have to classify applications or groups of applications and users or groups of users. But once you have those labels in place, you can tell the system, okay, have our real-time applications, you know, work at such and such level of quality of service. And other stuff for low priority users, like guests on our Wi-Fi that are doing non-work things like looking at Facebook, you give those lowest priority, right? The new model, you label all the things, all the components of the network, and the system is going to configure itself to achieve your operational goals. It is a big thing, and it's much easier for the humans, because once you've put those correct labels in place, then you kind of just monitor it to see what's going on. Some other features about it that are really neat in, for example, some of the, you know, state-of-the-art Cisco systems, system awareness and self-correction. Okay, we'll take a minute to talk about that, then we'll call it a day. So, in the old days, what would happen, how people would recognize there was a problem, right? Your network traffic would reach a point, reach some kind of crisis point, and crash. Okay, so I'm just drawing this as some kind of sawtooth pattern. Okay. Old model, humans would track the network state, right? When a problem happened, humans would fix it. Okay, so when the network gets busy, eventually it gets overloaded, maybe some things crash, humans have to intervene. Now, what is possible, current model, right? The system will recognize when a failure is imminent, right? Because it can look through your past data and say, oh, you know what, this situation that we see here, this is a lot like these other past failures that we saw. And when you start approaching to that point, right, we say, don't fix it here, add capacity here by, you know, starting new servers, right? By making more system capacity available prior to when you need it. This is better because hopefully the system never actually fails, right? It keeps up and operating the whole time. So this is kind of a neat thing. Of course, to a point, it also has the seeds of its own trouble, right? Because if you never have the system start to go south a little bit, then you're never really going to recognize where the problem points are. So there's still some interesting scope there for how careful you want the system to be set up. But yeah, in principle, it is generally better than the old model where you wait for the failures to happen, then the humans intervene and fix it, right? It's nice if you can fix this stuff in advance. Now, part of the problem, why it's necessary, systems changes happen more slowly 20, 30 years ago, right? You would see that traffic was building up, and yeah, at some point the system would get overloaded. Nowadays, these traffic surges can happen quite suddenly. So the system needs to be ready to bring on new hardware whenever you need it. Just that there's so many more users out there and their actions are somewhat unpredictable. Yeah. So system surges are both bigger, stronger, more sudden. You need this kind of automated model that recognizes the problems before they happen. Okay. So anyway, that's some neat stuff going forward. I'm sure if you take some 400 level IDS courses, they'll have more to say about this by the time you take them. But for us, this is where the story ends. Okay, so I'm going to stop recording. I'm going to stop sharing. Any questions on any of this stuff? What's happening? How y'all doing?